And then you're also going to need to be able to like figure out what the closest integer is to that.
Hmm.
Right.
Because for this problem, I got a little bit like, confused.
Yeah, I
So,
mean, these do get trickier. So I'm just gonna, I'll be honest, like these things, like, when you start off with the 1 and 2, they're gonna be uh,
complex.
a little bit, yeah, like the earlier ones will be a little bit more doable and the later ones will be a little bit harder. So there are more questions here. So if anyone wants them, I can, in the chat, I can put in both the exam and the final solutions. Again, your iPad, your computer, whatever, you might not want to download PDFs or anything, but these are the official math counts ones.
Okay, we'll
So
get
if anyone
started here
wants
in a
them, you can
little
have them.
bit.
Um,
Yeah, and I'll
but
talk
like,
about
because if you
someone's
wanted to
asking
try
what's
the
a
later
target
number
round.
things,
We'll
these don't have
discuss that at
complete
the
solutions
start.
written up, but if you
But
search
I
on the
will say
internet,
you
there
can
are
use a
complete
calculator
solutions
today.
written up,
So if you have one
probably.
handy, or
Yeah.
want to go grab one, that's fine.
So
But you
it's
can
probably a good
also
spot to
on the
stop.
computer,
So what
tablet, phone,
we'll
whatever
do
you're
over the next
using,
few weeks is I want to
you're
just try to
welcome to
introduce you
use
to the flavor of some of
your
these
calculator
tests.
app.
So we'll look at a target test, which is like a different kind of thing. We do two problems at a time. We'll look at an AMC8, which feels a lot like this, except there's multiple choice. And maybe we'll even do some countdown round stuff where we kind of just like,
So
we need to
next
answer
week,
fast.
so
Hmm?
next week, we're going to finish this sprint round test.
Next week we'll do a different kind of test. So usually like with this, I want to kind of start with the easier questions, but then when we get to the later questions, it does get a little bit more difficult. So these are things that if you want to work on them, you can kind of work on them. But we're going to do something different
Okay,
next
so
week.
it's 10. Yeah.
Any other
I know
questions?
we probably are going to have a smaller group
No?
today because there's another event going on at
Alrighty. Well,
K-State,
I'm going to
the
wrap up this
Grow
session and
event,
I
so
hope
we
you all
might
have a
have a
wonderful
kind of
weekend.
smaller numbers than Thank you. usual. Bye.
Bye.
So in large part this semester, we've been
Thank you. Have
covering
a
all
great
this
day.
background
Yep, you
material,
too.
and we kind of saw a lot of different little things, all that are kind of fair game for these tests. So what we've been doing last week, this week, and quite likely next week is we're looking at some of the different formats we have for these tests and what they look like, just so you have a little bit of practice on them. Um, so last time we were doing the sprint round, which is the 30 question, really kind of fast. That sort of feels in a lot of ways like an AMC 8. Today, what we're going to look at is a different round. This is the target round. Now, the target round is not just one big test. Basically, it's four mini rounds. They give you a pair of problems at a time, and they give you 6 minutes. And so what we're going to do today is I'm going to give you four different pairs of questions. I'm going to give you 6 minutes to work on them, and then we'll go through the solutions round by round. Uh, you know, so so basically, so how these things work, you are allowed to use a calculator in the target round. The sprint round that we did last time, you're not allowed to use a calculator. So in a large part, it's kind of a goofy format. You might ask, why don't they just give you 8 questions out in one go and let you work on it? The real answer is behind the scenes, when you're at one of these contests, they're grading. And they're trying to get all the grading done by the time the team round ends so that they can figure out who's going to be doing the countdown round. So usually when you go to a math counts competition, you're going to have the sprint round first. That's the one that takes the longest for them to grade. They're going to do these four mini rounds in the target round where they give you a sheet of paper, you do it, and they're going to take it. So you can't go backwards and work on the problems you already submitted. You can't work ahead. You're just giving those two problems at a time. And in large part, they're trying to get ahead grading. And then after that, if you're in the four people from your particular team, you're allowed to do the team round. And then after that, they have the kind of buzzer countdown round. We can talk a little bit about that in another session. One thing I was also going to note, I did email parents and guardians about this. There are some people trying to make a math counts team for Eisenhower Middle School here in Manhattan. So if you were particularly interested in that, I've heard from like two people. But if you're interested in doing this and you're at Eisenhower Middle School, please let me know, or have your parents or guardians let me know. Okay. So, some other things to just kind of know about the target rounds. This isn't always the case, but it frequently is the case that of the two problems, there's going to be one that's a little bit easier, that is a little bit faster, and then there's going to be one really challenging one. And so oftentimes the easier one is the first of the pair, but that isn't always the case. And it isn't always the case that there's an easier one. But like oftentimes they have easier one in each particular set. And in large part, this is used to differentiate people kind of going into the countdown round where they're determining who gets to do the buzzer round. So if everyone's set and ready, we are going to look at the first two problems. I'm going to give you 6 minutes, and then I will go through those two problems. And I'll have a handy dandy timer going. And if you have any questions in the meantime, feel free to toss it in the chat. Alrighty. So that would have been 6 minutes, and I can give you verbal warnings. Someone suggested like just say 1 minute, 2 minutes. Usually in the competition, they'll do that. They'll say 1 minute left or 2 minutes left, things like this. But it kind of depends a little bit on the particular site that is running it. So let's take some time and look at these two questions. And these are particular ones that a calculator might make it a lot faster to do if you're especially if you're fast at typing things on your calculator. So this first one, there's a couple ways to do this. You could try to start dividing stuff and then see if you get messy decimals coming out. That would totally work, at least with a particular number that we're looking for. I mean, there is a little bit of an issue because we have some 2s and 3s in some of the factors. But there is a very sneaky way to do this. Because if I multiply all these numbers together, 1 times 4 times 6 times 9 times 15 times 17, and you'd need a calculator probably to do that, you would get this. So this is the product of all the numbers. And as someone said, then if you divide the product of all the numbers so we said we're multiplying 5 of the 6 numbers together. We don't know which of the 5. But if I have this 55080 and I were to divide it by 3240, this would tell me which of those 6 numbers is left out. So if you were to plug this into a calculator, you would get the answer of 17. Because we have on the top, I have the product of all 6 numbers. On the bottom, I have the product of the mystery 5 that I don't know which ones they are. But if I do that, those mystery 5 would cancel out with all the ones that I have upstairs, leaving me just with the 17. Is this okay? Okay. And if you have any questions, you can put it in the chat, pop your mic on, and we can always go back to the prior thing. Someone says I can't see yours. Can other people see my screen? Is there a question? Yes, people can see my screen? Okay. So I'm not sure. It might be in your setting. So the person who can't see the screen, it might be in your settings. You might be like in speaker mode versus you might need to go like click on view to see this. Was there a question? Have a hand raised? No question? Okay. Okay, so this second one, I just want to say, like, a calculator is your friend. This is an absolute beast to do without a calculator, and quite likely you wouldn't be writing this on your paper, assuming you kind of know what the formula needs to look like. So if we look at this thing, we have each one of these kind of bars on this this histogram is going to give us some information. So for instance, we know that one person that we have one, these values was 8, we have 1 was 11, we have 2 were 12, we have 4 were 14, we have that 6 were 15, we have that 7 of these things were 16. We have that 2 were 17. We have that 3 were 18. And we have that 4 were 20. So that's what I would get if I added up the scores of all the students, right? Then if you were to divide by the total number of students, so what I have on the top is what I get when I add up all the scores of all the individual students. Because like, for instance, on this one, this being up here at 4 means that 4 of those students scored a 14. So then you got to divide by the number of students. Well, the number of students was, I have 1 student here, 1 student here, I have 2 students here, I have 4 students, I have 6 students, I have 7 students here. This is another 2. This is another 3. and this is another 4. So this is a big mess to plug into a calculator. And as someone said, like someone's calculator didn't kind of wasn't able to handle an expression that large. And this is one thing, like, have a calculator that you're comfortable with for the contest. So if quite likely your MathCounts coach has a set of calculators that they might be bringing, and it's probably what's typically used in your school. It might be a TI-82 or 84 or maybe something else. But if you don't know how to use it, then it can be kind of complicated. So if you're to type all this stuff into your calculator, you get 469 divided by 30. This would be very hard to just do in your head. And if you were to do that division on a calculator, you get 15.63 repeated. Now, one of the most important things with the MathCounts test is they want the answer in a specific format. And they don't have multiple choice like the ANC8. So it's very important that you give them the answer in the format that they want. They're saying round this to the nearest 10th. Well, so if I round this to the nearest 10th, I would end up with 15.6 as my final answer. Because if you would have given them the more accurate answer, 15.63 repeated, they'll actually mark it wrong because they view part of the problem is the rounding step. Is this okay? Anyone have any questions on this one? Okay, I will set the timer and we'll post another 2 questions. Okay, so towards the buzzer, I was getting a lot of questions and things simultaneously. So we'll just kind of go through the problems now. Okay, so let's first do this one. So this is something that a calculator can help you to do pretty quickly, but you got to keep track of should I be multiplying or dividing every single time. So I'm going to kind of write out the steps, which is probably not how you'd write it out on a speed-based test, but a way that you'd be thinking about this potentially. So we're given that there are 88 measures. And when we look at this, we're saying that each measure contains 16 notes. So if I want to kind of figure this out, the second fraction, 16 notes divided by 1 measure, this would be the same thing as a conversion factor, like 12 inches is the same thing as 1 foot. So in some sense, we're kind of multiplying by 1 here. But what we see here is that this would convert, this would tell us how many notes we have because the unit's measures would drop off. Then we are given that in a typical performance, 432 notes are played. In a typical performance, yeah, so every minute. So we can do another conversion factor, 432 notes would be played every 1 minute. Because this would enable me to get rid of the unit's notes. And now when I do this multiplication and this division, I'm left with some number of minutes. But they're saying one thing that's important here is they want us to express your answer to the nearest second. So we do one more conversion factor, 60 seconds per 1 minute, which would enable me to get rid of the unit's minutes. So if I have 88 times 16 divided by 432 and then multiplied by 60, we would get an answer, and a calculator is probably necessary to do this. You get 195.5 repeated. But we always have to give the answer in the way that they want it. So they're saying that we're supposed to round our answer to the nearest second, right? So because we're at 195.5555555, we round up, and your final answer would be 196. So okay. And if anyone has any questions, again, you can raise your hand, toss things in the chat, and we can kind of go back as needed. This next one, in general, if this was just an arbitrary thing, would be a very, very tricky question. But one of the things that you see a lot is if they put in triangles, they tend to put things that have kind of specific patterns that you can identify that might make the question a little bit easier to do. So here we're given that the diameter AB is 8. So this would tell us that the radius here is 4. We're also given that the length of BC is 4 times the square root of 2. And if we look at this, what we see here is, okay, this is pretty nice because if this is a radius for the mic, the mic won't be unmuted. You have the, so we have a question. I actually can't turn your mic on. I can ask you to turn your mic on, but this might also be a setting in your computer that's not allowing you to do it. But you are allowed to actually unmute your mic. I don't have that parameter set here. I don't know why the microphone is not letting you do it, but I don't actually have the option of turning your microphone on. Okay, so we know here this is another radius, so this would be of length 4. And one thing you kind of note here is 4 squared plus 4 squared. You know, if I have these things being the same length, this is going to tell us that we have a very nice situation here. So we can kind of see here that this angle is actually going to be a right triangle. You know, this is going to be a right triangle. Which also tells me that this thing over here is a right triangle. And then this actually makes this question sort of doable. You know, because in general, it looks pretty intimidating at first, but I can find an area of one of these right triangles, 1/2 base times height. And if I look at what I have here, this is what I would get if I cut the pizza into 4 parts. This is a quarter of the overall area of the circle. The area of the circle is pi times the radius squared. The radius is 4. And if you're doing this, so this would simplify to 16 divided by 2 or 8. This would simplify. I could cancel off one of the 4s and leave me with a 4 pi. Now, I saw some people give the answers like 8, or I think people found like kind of parts of the question. So one of the things that you always want to do on a MathCounts test is say, okay, your final answer looks like this. What is the value of AB? And this is lowercase AB. It's a little bit confusing that they use uppercase and lowercase things, and you have expressions AB and AB. I don't particularly love that they did this, but I am cutting and pasting from the MathCount. Like this is the actual way that this was stated in the MathCounts test, not how I probably would have written it myself. But if we look at this, if it looks like A plus some number times pi, so what they actually want you to calculate is 8 times 4, and your final answer would be 32. So yeah, if there are no other questions, we can look at another pair of problems. So let's go over these problems. And so, and one thing that's always that kind of came up with a lot of the answers I saw is just like they usually like state how they kind of want their answer at the end of their question. So here in this first one thing to note, they want you to give your answer as a decimal to the nearest tenth. So we have this baseball diamond, and the baseball diamond is this square, right? And so I can figure out what the area of this is. It's not the worst thing on earth because the area of a square is just going to be the square of the side lengths. So we'd have 90 squared square feet here. Now I want to convert this into acres, right? And I'm given a conversion factor here that 1 acre is the same thing as 43,560 feet squared, or square feet. And note, what I have here, this fraction I have in red is just a very fancy way of multiplying the number by 1 because what I have in the numerator and the denominator exactly matches, or they mean the same thing. Okay. Is there a question with the thumbs up or? Okay. So if we're looking at this, I can cancel the units feet squared. And this would leave me with, well, I need to plug into my calculator 90 times 90 divided by 43,560. And I would get the number 0.18595, you know, it kind of keeps going like this, right? So here is where you say they want our answer as a decimal. So if I'm converting this to a decimal, this is 18.595 ... percent. And if I round that then to the nearest tenth, I'm at 18.6% for that. So I had some different numbers kind of coming up in the chat, and potentially some of us might have just had 90 divided by the 43,560, or it might just be a typo. You typed in the wrong number, or something else happened. I had a hard time diagnosing what some of those were, but most of the issues I saw were in kind of the converting to a percent and rounding stage. And if anyone has any questions, we can kind of go back and look at that more. This second question, though, is a little bit more of a beast, in my opinion. But, you have kind of multiple things going on with this particular problem. So we have this triangle, and we're trying to visualize this, and we're given some lengths, right? So we also know some other lengths just because this is, a nice rectangular box. So this thing would be 6. This part here would be 6. This part here would be 8 for this length. And what I probably want to do is I want to be able to figure out what this triangle looks like. Because if I can figure out what the triangle looks like, then I'm going to be able to find the area of the triangle. And it might be a little bit hard to do this on the regular diagram. But I see some of these lengths I can use the Pythagorean theorem for, because again, this is a 6, 8 something triangle. And one of the things you might want to do is some of the, some of those Pythagorean triples that come up all the time, the 3, 4, 5, 6, 8, 10, you might want to have memorized, but you could do this. You could figure it out. We know that 6 squared plus 8 squared is going to be, say, whatever this length is, if this was x or z or whatever we want it to be. Let's call it z. And so what we'd find here, if we add this up, we get 100 is equal to z squared. So our z is equal to 10. So we know what this length is. But similarly, this triangle I have up top is also a right triangle. And we see that its length, of that diagonal thing here from P to R is also going to be 10. So when I'm looking at my triangle, I know that it's going to be isosceles and two of these things happen to be 10s. Now, I still need to figure out what this length is here. And again, this is something very similar to what we saw in an earlier problem. I mean, if these side lengths are the same, you have 6 squared plus 6 squared, if this is c or something like this, is equal to c squared, you'd find that c squared is going to be equal to, 6 squared times 2. So 6 squared times 2. So your c is going to be the same thing as 6 root 2. Okay, so this bottom length here is 6 root 2. And one way that we might be able to do this is we could chop this triangle in half. If I do that, because I have an isosceles triangle, I'm going to get right triangles here, where this length is 3 root 2, this length is 3 root 2. And if I want to use the area formula, again, there's other ways you could figure out what the area is here. And you might have some formulas memorized or stuff like that. But if I want to figure out what this length here is, I know that 3 root 2 squared plus a squared is equal to 10 squared. So this is going to tell me that a squared is, 10 squared is 100. 3 squared is 9. The square root of 2 squared is 2. So this is 18. So we get a squared is 82, which would tell us that a here is the square root of 82. Okay, so we've done a lot of work, but we actually don't have the final answer yet, right? So I need to find what the area of this triangle is. And the area is going to be 1/2 times the base. Well, the base is this entire length, or I know what 1/2 of it is already, because 1/2 of it's going to be 3 root 2. But 1/2 times 6 root 2. And then we know what the height is. This is root 82. Now, this is a little bit ugly, and this is not a simplest radical form. They want you to kind of write the number as nice as possible. So I could maybe initially divide into 2 into the 6, which would give me 3 root 2 root 82. Now, note, like root 82, I don't have any square factors in it, but I do have a factor of 2. And if I rip out a square root of 2 and multiply it by this square root of 2, then this would be the same thing as 3 times 2 times root 41, and you'd get a final answer 6 times the square root of 41. And this is going to be in simplest radical form, because I can't really take anything out of this square root expression without making things worse. I have a question for question 5. Wouldn't you write 18.6 for your answer? Yes. So if you're actually are on a test, they're going to have an answer thing here, and it is going to have a percent here. So you would just write 18.6. So you are correct. So you wouldn't write 18.6% percent. Yeah. And in large part, you're going to write the units for all these things. And so the weird rule with MathCount is if you write your units, that's okay. But if you write the wrong units, like if they ask you for feet and you have the correct answer and you say 72 inches, they will actually mark it wrong because you corrected their units or something like this. So, but yeah, like on the actual answer blank, it would have 5 and you'd have a thing and it would already have the units percent here. Similar to, they would already have the units like acres or sorry, not acres. They'd already have the units, like in a problem like this, they'd have the units here and it'd be like seconds. And so you just write the 196. Good question. Some of those problems are kind of confusing in the target rounds. Yes. I mean, the target round is a very hard round because you get kind of 2 longer problems. The sprint rounds are usually things that can be done a little bit quicker. But also with the sprint test, once you get into the higher number questions, they can be incredibly challenging. Like usually the final 5 questions on a sprint round, whether it's even chapter level, and especially at the state or nationals, can be incredibly difficult. Okay. So we would be able to do this. And again, what we've kind of seen with this particular year, usually the first of the 2 questions, not saying it's easy. They're still quite challenging, but usually the second question out of each one of these sets is the much, much more challenging one, right? So they usually like to have one that's a little bit more approachable and then one that's really like that, not everyone's going to get right, to be honest. Okay, so let's look at the final pair of questions. And usually the difficulty kind of goes up with the rounds, but not always. Sometimes question 8 is not the worst question by any means, but it depends. So we can go through these questions. I mean, and just to note, question 8 is usually exceptionally difficult. So if you didn't really know how to start question 8, that's totally fine. I didn't actually, see much for answer. I only saw one person try to answer that question. So. But let's look at 7. So 7 is kind of tricky still. You might want to just, when we kind of break this down, we know that we have each row of books is going to have, 54. So each row is going to have about 54 books. We know we have 8 floors. And then what we might want to do is try to figure out, well, how many rows do we have? So when we think about the number of rows, we have a different number of rows on the big shelves and on the small shelves, right? So on each of these 8 floors, we have 22 large shelves. And we're given that each of those 22 large shelves has 16 rows of books, right? So this would be the number of shelves we would have kind of coming from the large bookshelves on a particular floor. Also, on each of these 8 floors, we have 14 small bookshelves. And each of these 14 small bookshelves have a total of 4 rows. So what we'd have here is we have 8 floors. This would be the number of rows that we have on each particular floor. And this would be the number of books per row. And so if you multiply all this stuff together, you would get 176,256, but you need to use a calculator probably to do this. This is probably not mental arithmetic unless if you're particularly skilled at that. And then note that it asks you to round to the nearest 1,000. So when we round, we have 176,000 would be your final answer. So there's a lot of pieces to this. And just note, a lot of problems like this, you can do this in different ways. There's not one way to solve a problem. You could just figure out first how many books are on a small shelf, how many books are on a big shelf, and then try to figure out how many big shelves and small shelves you have just by thinking about the number of floors you have and the number of large shelves that you have on this. So you could break this down into a lot of pieces, but if you're trying to do it in a speedy fashion, we have this. And one thing to note, usually these pairs of problems do get harder as we go. So usually question 7 is going to be harder than questions 1 and 3, and question 8 is going to be a lot harder than questions 2 and 4. But not always. It's not always like the case that this is true, but this is just kind of a general thing looking at many different math counts contests over the year. So let's finally take a look at this number 8, which usually question 8 is not solved by all that many students at any particular contest. And question 8 on the state or the national tests are usually quite difficult. So, but we have this machine that's going to randomly pick a number through 1 through 9 4 times, and it's going to multiply all these things together. What is the probability that this machine is going to generate 4 numbers such that when we multiply them together, the product is divisible by 14? Now, there's multiple ways to do this problem. I'm going to do one particular approach, which we talked about a little bit when we did our probability unit. So when we did our probability unit, one way to figure out the probability of something is to try to figure out the probability of it not happening. Because we know the probability of something happening and not happening together add up to 1. So we call this complementary counting or complementary probability. So, okay. So if I ask myself first, how can I do the opposite? So if you think about being divisible by 14, if I'm divisible by 14, you would need an even factor and you also need to have 7. Right? So one of these numbers would need to be 7 and one of these numbers would need to be even. You could have 3 of them be even and a 7 and it could work out too. But that's the 2 ingredients we need to be divisible by 14. So we need to be divisible by both 2 and by 7. Okay, so if I'm trying to count the opposite thing, I could first think about how likely is it that I have no evens? So that means that A, B, C, D all happen to be odd. Well, so we don't actually have 10 numbers here. We have 9 numbers here, right? And each of these things, like the probability that A is an odd number is 5 out of 9 times, right? So we'd have to have A is going to be an odd number 5 out of 9 times, B is going to be an odd number 5 out of 9 times, C is going to be an odd number 5 out of 9 times, and D is going to be an odd number 5 out of 9 times. So we'd find that the probability that none of these numbers are even, that they all happen to be odd, is going to be 5 divided by 9 to the 4th power. Okay. We could also similarly, figure out what the probability that we have no 7s. Well, in the numbers from 1 through 9, the probability that A is not a 7, well, it could be any of the other 8 numbers out of 9, right? So the probability that A is not a 7 is 8/9. The probability that B is not a 7 is 8/9. C is not a 7 is 8/9. And D is not a 7 is 8/9. So we get this would be 4, or 8 over 9 to the 4th power. Now, this is a little bit more tricky because we also had kind of overcounted here. So this is, our whole Venn diagram stuff. So I found the probability of no evens. I found the probability that we have no odds. But there are going to be some combinations that have no evens and no odds that we're kind of double counting. So if you're thinking about this, out of these numbers, 4 of these 9 numbers are even. One of them, no, 7s. So we have 4 of these numbers are even, 4 of these numbers are even, and one of these numbers is 7. So this is leave us with 4 numbers left over. Namely, you could be 1, 3, 1, 3, or 5, or 1, 3, 1, 3, 5, or 9. So there's 4 of these things are both not even and not 7. And so the probability of that happening would be 4 over 9 to the 4th power, kind of in a similar way that we did our last ones. So if I know the probability that I don't have an even, I know the probability that I don't have a 7, and I know the probability that I don't have an even and don't have a 7, we can use that thing that we talked about called inclusion exclusion when we talked about probability. So the probability that, I have no even or I don't have no 7, it's going to be the probability that both of these things, the probability of no evens plus the probability of no 7s minus the probability that both of those things happen. Because if I count the things here and I count the things here, I've double counted this intersection. Now, this is something a calculator is going to be your friend on. This is not easy to do in your head. So if you're to plug this in, my denominator, all these things are going to have a 9 to the 4th power. My numerator here, I have to have 5 to the 4th plus 8 to the 4th minus 4 to the 4th, which happens to be 4,465. And I plugged this into my calculator before this session. So if you want to have the probability that you have an even and a 7 out of your 4 numbers, it's going to be 1 minus the probability to have no evens or no 7s. There's even a little logic kind of tossed in, so we have our logic unit, our probability unit, all kind of coming together in one thing, which is why this is a number 8. Number 8s are usually quite difficult. So when I do this subtraction here, I get a 2096 over 6561. So someone asked, what is inclusion and exclusion? So if I want to count things and I have two things, A and B, this is going to be, the probability that they both happen. So you'd count your probability of A happening plus the probability of B happening, but you'd subtract the probability that both happen. So we did that back when we did our probability unit. Okay, someone's asking if you can leave. Yep, you can leave at any point you want. That wraps up our session today. I know question 8 is a little bit of a beast, so I don't want you to be intimidated. Like there's a lot of question 1s on test 2. So, and always when you do these practice tests, you're competing with yourself. We don't have to get everything right. This isn't like a quiz in school where we're always trying to get an A and stuff like this. It is very hard to get 90% of these questions correct. A lot of it is, especially when you're getting used to these things, is just try to get those first few questions, like, question 1, 2, 3, 4, 5 on a sprint test or something like this, or question 1 on a target test. Even if you don't get 2 through 8, that's okay. As long as you have fun doing it and you learn some math on the way. So if anyone has any questions, I'll stick around. But otherwise, I hope you have a lovely weekend. And thanks for joining us. And we'll do some more practice on tests as we kind of gear up for MathCounts and the AMC8 in the coming months. No one has any questions, I'm going to close up the session, but I hope you all have a great weekend. See you next week.